right? Do you know how to prime factorization of numbers, right? Prime factorization of numbers. We can do prime factorization of a number in only one way, irrespective of the order of that series, right? Look at here theorem. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur, right? You know already how to do prime factorization. I will explain. By using prime factorization also you can find out that HCF and LCM, right? 12 and 18. I will explain 12 and 18 prime factorization, right? Look at here, 12 prime factorization, 2 6 times 12, 2 3 times 6, right? 3 1 time 3. I can write prime factors of 12, prime factorization of 12 as 12 is the composite number, right? Right now 2 into 2 into 3, right? We can take it as 1, that is your wish. 1 is not prime number, there neither prime nor composite, right? There is no need of taking that 1. Right now I can write it as 2 here, 2 times it is multiplying, right? 2 raised to the power of 2 into 3. And now I will find out prime factorization of 18, right? And 2 9 times, first start with 2 only. While you are finding prime factorization of number, first start with 2 only, you will get good conclusion. You can write 3 into 3, and again I can write 3 into 1. 18 can be written as 2 into 3 into 3. I can write it as 2 into 3 square, right? This is the prime factorization of two numbers. From this prime factorization I can find LCM and HCF. LCM and HCF. Look at here, HCF is nothing but common prime factor which is present in the common factors of 12 and 18, and that should be least. Right here we have 2 as common factor, right? 2 as a common factor. Look at here, you will understand here, product of the smallest power of each common prime factor of the numbers. Smallest power, when you write exponential form of the prime factors, you will get powers, right? Product of the smallest power of each common prime factor of the numbers. This is HCF, and LCM, product of the greatest power of each prime factors of the numbers. Okay, I will explain here. HCF means common factor should be present in between both the numbers factors. What is the common factor? 2. Here 2 is present here, right? What is the exponent of this 2? 1. What is the exponent of this 2? 2. Here in both of the factors we got 2 as prime factor, and then from that 2 in above the 2 we have 2 exponents, right? In the 12 prime factorization we have exponent as 2 for 2, and in the prime factorization of 18 we have exponent as 1 for 2. And which is smaller here? Which exponent is smaller? 1, right? That you have to take 2 power 1. And here also same thing. In the prime factorization of 12 we have 3 power 1, and in the prime factorization of 18 you have 3 power 2. Which exponent is smaller here? 1, right? Therefore you have to take 3. What is the HCF now? 6. And while coming to the LCM, irrespective of the common, right, whether it may be present common or not, you have to take highest power of the factor, right? Here look at here, we have 2 is there, here also 2 is there, then you can go for highest. If there is no 2 here, if there is no 2, suppose if there is no 2 here, then go for directly 2 square here, right? Now we have present 2 present here, that is why we will check whether which power is highest here. That means 2 square here, and here between these two numbers 3 square is the highest, right? That means LCM of 12 and 18 will be 2 square 4, right? 3 square 9, 4 9s are 36. Its LCM is this one, HCF is this one. You can look at here. LCM is 36, HCF is 6, right? And the next one, and before I think we might have forgotten one question, right? Right, we'll see that question, right? Consider the numbers of the form 4 power n, where n is the natural number. Check whether there is any value of n for which 4 power n ends with a 0, right? We'll do that question. I think example 3, that is, we need to check whether 4 power n ends with a 0, right? Ends with 0. Look at here. Look at here. Here, if you take 4 power 0, you will get anything power 0 as 1. 4 power 1, you can take value as 4. 4 power 2, you will get 16. 4 power 3, you will get 64. And 4 power 4, you will get 256. Look at here, every number ending with either 4 or 6, either 4 or 6. Then by looking at that question, we can conclude that it will not end with 0, but we need to simplify by right, we need to explain that, right? Can I write I can write 4 can be 2 into 2 whole power n, right? I can write 2 into 2 whole power n, right? If a number ends with 0, if any exponential form ends with 0, that should consist of 10 in the base position. 10 in the base position. Here there is no 10 in the base position, right? Look at here. If 10 is present in the base position of any exponential form, you will have 2 and 5 are the prime factors for that base, right? Here we have only 2 and 2 are the prime factors, right? 2 and 2. Therefore here only 2 is the prime factor for 4, right? A number, an exponential form, means this is ends with the 0 when it has 0 in there, when it has 10 or multiples of 10 in their base values. Here there is no 10 in the base. Therefore, four power n will not ends with the 0, right? This is the explanation. you can go for 2 into 5. 10 as 2 into 5, right? Yes, okay. Now we will discuss 1.2 exercise. Right, prime factorization we have done with the one example, right? I will take this question for finding prime factorization 1.2. Look at here, 3825, right? That question is 3825. 3825, right? First I will check two table. It will not be cancelled in two table, right? Why? Because all the even numbers are only divisible by 2, right? Now I will check whether it will be divisible by 3 or not. 3 plus 8, 11, 13, 18, right? The sum of the digits is 3 multiple. Then I can conclude that this number is divisible by 3. 3 1 times 3 and 3 2 times 6 and 2 is the remainder, right? 2 and 2 will become 22. 3 7 is 21, 1 is the remainder, 15, 3 5 is 15. Again I will check whether the number is divisible by 3 or not. 1 plus 2, 3 plus 15, right? 3 again it will be divisible by 3 4 is 12, 3 2 is 6, 1 is the remainder and 3 5 is 15. And again I will check whether it is divisible by 3. Okay, it will not divisible by 3 and I will go with the 5. 5 8 is 40 and 2 5 will become 25. 5 5 is 25. Again 5. 5 1 is 5 and what is the remainder here? 3. 5 1 is 5, the remainder 5 7 is 35, right? This 17 is also prime number, right? Then I can write prime factors of 3825 as 3 into 3 into 5 into 5 into 17, right? You can write it as exponential form, 3 square into 5 square into 17, right? This is the prime factorization of 3825 and you can do rest of the problems. You may get 2 marks question from this, right? And the next one, right? Find the LCM and HCF of the following by using prime factorization method. Can we go with the I will explain first question, you can do rest of the questions, and otherwise here three numbers are there, I can go with this one, right? 12 15 and 21, right? 12 15 and 21, right? 2 6 are 12 and again 2 3 is 6. These are the prime factorization of 12 equal to 2 square into 3. 15 can be written as, I will go with the 3 5s and both are the prime numbers enough for here. 3 into 5 and 21, I can go with 3 table only, it will not be cancelled in 2 table. 3 7s, 3 and 7 will become prime factors of that number, 3 into 7. Look at here, while finding HCF, the exponential should be present in all the prime factorization exponential forms, and then that least that should be, we have to take that least common prime factor, right? Look at here, 3 is there, 3 is there, 3 is there in all the prime factors we have 3, right? What is the least 3 is common in all the prime factors, right? And then irrespective of the exponent, we have to take least exponent here. Here all the exponents of 3 is 1 only, directly you can take 3. And do you have any common factor for all these 3? Here 2 is there, here there is no 2, right? Here 3 we have taken already. That's it. HCF is 3. And LCM, we have to take highest power exponential form, and there is no need of checking whether it is common or not. Here 2 is there, 2 power 2. Do you have any 2 exponential form which is having base as 2? Right, no. I will take directly 2 square 3. Between these, among these 3 3's, only 3 power 1 is the highest exponential form. Again 5 is not present in all the numbers, right? Anyway we have to take that one. That is also highest, right? If you have 2 exponential forms which are having 5 as base, you can take highest power exponential form, right? And then again 7 is present in only prime factors of 21, but 7 is not present in 12 and 15. But anyway I will take here, irrespective of common factor, whether it may be present in all the factors of 12, 15 and 21, right? 2 square 4 3 5 7, 4 3 is 12, 12 5 is 60, 67 is 420, 420 is the LCM, and 3 is the HCF. You can do rest of the problems in this model. And then next one, check 6 power n can end with the digit 0 for any natural number n. Look at here, same question. Right, now next question, we'll see the next question. Check whether 6 power n can end with the digit 0 for any natural number n. We have done this question previously, and again I will explain. We have done previously for 4, and here I will explain orally. You can see that question again if you want. 6 power n, 6 power n can be written as, I can write it as 2 into 3 whole power n, right? If any number which ends with 0, right, the exponential form of that number should consist of 10 as base or prime factors of 10, right? Prime factors of 10, right? What are the prime factors of 10? 10, 2 and 5. Here we have only 1 2, right? Here we have only 1 2, there is no 5. Therefore I can conclude that 6 power n will not end with 0. 6 power n will not end with 0 for any value of n, right? This is our conclusion. You have to write the steps which I have written for the 4 power n, or otherwise you can write in your own way, which can be gives the information about this 2 into 3, right? And also you can observe this 6 power n ends with 0 or not by looking at the question. 6 power, if you take 1, right, 6 power 1 equal to 6, 6 power 2 equal to 6, any power of 6 will give us 6 only, right? There in ending 6, right? Therefore I can conclude that 6 power any number will not end with 0, right? Done. Thank you. And next question, right, I will explain here itself because it is a little bit big question, right? Right, look at here. Here 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 1 plus 5 are composite number. We need to write why are composite numbers. Okay, what is mean by composite number, what is mean by prime number? Before that we need to discuss that one, right? prime number only two factors, right? Prime number have only two factors, right? That is 1 and itself, right? For suppose 2, 3, 2. What are the factors for 2? 1 comma 2. These are only the factors for 2. Therefore, I can conclude that this is prime number. For 3, 1 and 3. For 4, 1, 2, 4. Here we have 3 prime factor. It is composite number, right? Prime factors means which has only two factors, itself and 1. And composite number means which have more than two factors, right? Here 4 is having more than two factors, right? That then we can conclude that 4 is composite number. The numbers which are having two factors, only two factors, one is itself and another one is 1, those are called as prime numbers. The numbers which are having more than two factors, those are called composite numbers, right? And now we will discuss that question. We need to prove, right. Next one, what is that fourth question? 7 into 11 into 13 plus 13. First one is this one. Second one, 7 into 6 into 5 into 4 into 3 into 1 plus 5. We need to explain why these two are not prime numbers, right? I can write it as, can I take 13 as common between these two terms? If I take 13 as common, 7 into 11, 77, plus already we have taken 13 as common, we will left with 1, right? 13, 78. Here, look at here. Here we have a number which has factors as 13 and 78, and also here I can write 1, right? Here the number, irrespective of the number, whether we can get any number here, the result of this multiplication is any number. But here we are getting three factors, right? 13, 78, 1. For prime numbers, we will get only two factors, right? That number and 1. That number and 1. Here we are getting three factors. Therefore, I can conclude that it is composite number. And here also same thing. 7, 6, 5, 4, 3, 2, 1. Right. If you simplify this one, 2, 3 is 6, 6, 4 is 24, 24, 5 is 120, 120, 6 is 720, 720 into 7 plus 5. Or otherwise you can go directly here itself, right? You can take 5 as common. You will left with 7 into 6 into 4 into 3 into 2 into 1 plus 1, right? Plus 1. Here 2 3 is a 6, 6 4 is a 24, 24 6 144, 144 into 7, 144 into 7, 8, 0, 7 1 is 7, right? 1008 plus 1. right? Here also I can write is as 5 into 1009, right? 7 for the 28, 7 for 28, 2, 30, and so on. Okay, done. Here also same thing, 5 into 1009 into 1. Irrespective of this result, what we will get here? What will we get here? We don't know. But here that number, that result is having 3 factors, right? Therefore, it is also composite number. Again, next question. Again, we will move to the next question. Right. We'll go to the next question. Right. Next question. Fifth question. How will you show that 17 into 11 into 2 plus 17 into 11 into 5 as composite number? Same thing here, same thing. If you take 17 into 11, here also we have 17 into 11, right? Take that 17 into 11 as common, we will left with the 2 plus 5, right? Here left with the 2, here left with 5, and 17 into 11 into 7, right? 17 into 11 into 7. These are irrespective of the result. Irrespective of the result, we don't know whether what result we get here, but the result consists of 3 prime factors, right? Here it's 3 factors, right? Therefore, I can conclude that it is composite number. You have to mention that one. The number have 3 factors. Therefore, it is composite number. Right? Right. Now, sixth question. What digit would occupy the units place of resulting number of 6 power? Right. Now, we will check 6 power 1 as 6, 6 power 2 as 6, ends with 30. 6 power 3 as 216, right? Previously I might have reached 10 now. Okay, 6 power 3 as 216, right? And any power of 6, any number as a power of 6 which ends with 6, therefore we can conclude that 6 power 100 also ends with 6. Clear? And the next one, next decimal expansion, right? Okay, next look at the decimal numbers. Convert this decimal number into fractional form. We will get 375 by 1000, right? For these 3 digits after decimal, we will take 3 zeros in the denominator, right? Otherwise into 1000 by 1000. Look at here, can I write this as 375 by 2 into 2 into 2 into 5 into 5 into 5, right? 2 5s are 10, 2 5s are 10, 2 5s are 10, 10 into 10 into 10,000, right? I can conclude that 375 by, here I will cancel, 5 1s are 5 7s are 30, 5 2 is the remainder, 5 5s are 25, and 5 1s are 5, 2 is the remainder, 5 5s are 5 1s are 5 3s are. Here I got 3 by 8, right? 3 by 8. And then, well, coming to the next example, we will left with the I will take 1.04. I will take 1.04. You can write it as 104 by 100. Right? 252 times 250 times and 226 times 225 times. Right? 26 by 25. Here 2 power 3. Here I can write 26 by 5 power 2. Look at here, why I will explain why am I explaining this one, right? Look at here we can call it as terminating decimal, right? Here it is also terminating decimal, right? It is also terminating decimal. I can tell this as terminating decimal. Right, now here, since these two are terminating decimals, you can observe in the fractional form for those terminating decimals, both of the fractional forms are having denominators as first one is 2 cube, second one is 5 square. Right, I can conclude that from here I can conclude that the decimal number which terminates is in the form of P by Q form, where Q, P and Q are co-prime numbers, right? Co-prime numbers, and Q should be in the form of 2 power m 5 power m, right? It can be in the form of 2 power m or 5 power n or 2 power m into 5 power n to get terminating decimal. That means I can conclude that the terminating decimals are in the form of fractional form with a denominator of 2 power m or 5 power n or 2 power m into 5 power n, right? And now vice versa, same thing. The fractions which are having denominator as in the form of 2 power m or 5 power n or 2 power m 5 power n are terminating decimals. Same vice versa, right? Previously we have discussed terminating decimals. The terminating decimals are having denominators as in the form of 2 power m, 5 power n, 2 power m or 5 power n. And now the fractional number which are having denominators as 2 power m or 5 power n or 2 power m 5 power n are terminating decimals, where m and n are non-negative integers, that are whole numbers. Right, now look at that example. Right, again we have to discuss something here, and here I have already explained you, right? As in the starting of the lesson, terminating decimals are rational numbers, right? Previous thing, this is related to this one. And non-terminating recurring decimals are also rational, right? We have discussed in the start while we are present in the starting of the lesson. Right, now that means 0.3333, so on, 0.5555, so on. Right, we can write it as 0.3 recurring, we can write it as 0.5 recurring, right? And the next one, same thing, right? And again theorem, Next theorem, the numbers, the rational numbers which cannot be written in the form of p by uh, for suppose the rational numbers which are written in the form of p by q, and q is not in the form of 2 power m or 5 power n or 2 power m 5 power n form. That is already we have concluded that as rational number, but the denominator is not in the form of 2 power m or 5 power n or 2 power m 5 power n form. Then we can conclude that rational number as non-terminating recurring decimal, right? If it is in the form of 2 power n or 5 power n, denominator only, I am discussing about denominator, 2 power m and 5 power n, multiplication of 2 power, that is terminating decimal, right? And then here if the denominator of that fractional number not in the form of denominator not in the form of 2 power m 5 power n 2 power m 5 power n, then we can call it as a non-terminating recurring decimal, right? We have discussed while starting of the lesson, right? Next one, example 5, right? Example 5, we will discuss this as early as possible. 16 by 120, 16 by 125, I can write it as 16 by 5q. It is terminating decimal, right? Terminating decimal. And then 25 by 32, 2 to the 4, 4 to the 8, 8 to the 16, 16, 25 by 32 can be written as 2 power 5, right? It is also in the denominator is in the form of 2 power m. In the first case, denominator in the form of 5 power n. Look at here. That is why I am directly looking at that question. I am writing this as terminating decimal. And again, what is the next question? 100 by 81. 100 by 81. 100 by 81. I can write it as 3 power 4. It is not in the form of either in the form of 2 power m or in the form of 5 power n. Therefore, it is rational number only, but it is non-terminating recurring, right? And then same next question, what is the next question? 41 by 75. I can write it as 41 by 5 square into 3, 25 3, right? 41. It is not in the form of 5 power n or 3 power n, sorry, 2 power n, 5 power m n, or you can take it anything here. Wait, I will explain again here. It is not in the form of 25 into 3. Look at here, 41 by 5 square into 3. If it is a terminating decimal, it should consist of 2 power m or 5 power n or 2 power m and 5 power n, right? Here 5 power m is there, for extra 3 power something is there. Therefore, it is also, we can conclude that non-terminating recurring decimal. And the next question is, write the decimal form of the following numbers without actual division, right? We will do that question. Example 6. Example 6. Write the decimal 35 by 50, right? 35. Can I write as 5 into 2 into 5? 5 to the 10, 10 5 is 50. I will multiply this number by another 2. Why? Because I will get 100, right? Since I am multiplying in the denominator, I need to multiply in the numerator, right? 35 into 2, 70. And here you will get 100. You will get 0.7, right? Right. Try to do the rest of the problems. And then next one, write the following rational numbers in their decimal form and also state exercise 1.3. We are discussing exercise 1.3. Write the following rational numbers in their decimal form and also state which are terminating and which are non-terminating repeating decimal form. Right, first we need to write decimal form, right? I will explain again one by one. Right, look at here, 3 by 8. First question is 3 by 8. First, by looking at this question, I can write it as 3 by 2, 3, terminating decimal. Right, terminating decimal. And again, I will multiply. I wanted to find out the decimal form of this number. I will multiply denominator and numerator by 5 power 3 to make that denominator as ends with zeros. The 5 5 are 25, 25 on 25. This will become 375. Right? This will become 10,000. And here you will left when you divide integer by 100 or 1000 or 10,000, how many number of zeros are there in the denominator? That many number of digits that decimal will move left side. You will left with 0.375. This is the first one. And the second one, 229 by 400. And again I can write it as 229 by 2 square into 100. Right, 2 square means 4, right? I can write it as 299 by, and here 2 square missed their pair. I will multiply with 5 square, right? 100. Since I am multiplying in the denominator, I need to multiply in the numerator, right? 5 square means 25. You can simplify this value, you will get answer. Yes, wait, I will explain here. 4 5 are 20, 2 is the remainder, 2 is the remainder, 4 5 are 20, 4 7 are 28, 1 is the remainder, 20, 5 7 25 by, right, 2 5 are 10, 100, 10,000, right? 100, 10,000. You will left with 4 zeros. You will left 0.5725 is the answer. And you can go for rest of the questions, and it is a terminating decimal. We can say that one. And the next one, coming to the third question, is also terminating decimal. You can convert that as mixed fraction. 21 by 5, 5 power something, terminating, right? 5 4s are 20, 4.2 is the answer. And then next one, fourth one is only the difficult thing, non-terminating decimal, right? Non-terminating recurring decimal. It is non-terminating recurring decimal. Why? Because fractional number which consists of 2 by 11, and it is not having either 2 power m or 5 power n, right? It is non-terminating recurring decimal. For finding this type of questions, we need to go division, long division, right? I will explain here. 2.0000, right? 11 is not, 2 is not sufficient to divide with 11. I am taking 2 digits here. I will enter into the decimal part. 11 ones are 11, and again 9 is the remainder. I will take 0 here. 11 8s are 88. 2 is remainder here, 0 here. 11 ones are 11, and again I left with a 9 and 0 8 88, and remainder 2, and it goes on. Therefore the value of this one is 0.18, and so on. And next question you can do easily, and without for second bit we will do the second bit. And the next question, second bit, without performing division, state whether the following rational numbers will have terminating decimal or non-terminating decimals. Okay, we'll get into the book here, right? I will show here. look at here. Second bit, without performing division, state whether the following rational numbers will have terminating decimal or non-terminating repeating. All these are factors, right? Find out the prime factorization of 3125. Right, 3 plus 1 4 2 6 5 table. We will go for 5 table. Why? Because it is not divisible in 3 table. 5 6 is 31, 5 2 is 10, 2 5 5 is 25, 5 125 times 5, 5 2 is 10, 2 is the remainder, 5 5 is 5 5. It is 5 power n something. It is, we can say that it is terminating. It is 3 into 4, right? 3 into 4. Here it is in the path of 2 power 2. 3 is extra here. It is, I can conclude that non-terminating repeating. And 455. I will go in 5 9s and 5 1s. Again 5 and 91. 91 is another thing, right? It is a non-terminating recurring. 16,000. 4 into 100. 4 into 100, right? 4 2 power 2 into 2 power 2 into, yes, I can write it as 16. I can 1600. I can write it as 1600. 2 power 4 into 100. I can write it as 5 power 2 into 25. 4 times 2 power 2. Right? Therefore, the decimal the fraction prime factorization of 1600 is 2 power 4, 5 power 2, 2 power 2. Then I can conclude that it is terminating decimal. It is non-terminating. 7 cube. It is 7 cube. I can directly conclude that it is non-terminating recurring decimal. Right? It is terminating decimal. It is, I can there terminating decimal. It is 5 into 3, right? 3 is extra here. Then non-terminating recurring decimal. It is terminating decimal. It's 3 7s, right? 3 7 into 10. Here even though we have 2 into 5, but 3 into 7 are extra things, right? Non-terminating recurring decimal. Right, next one. Third question, write the following rational numbers in decimal form using theorem 1.4. Right, theorem 1.4. Okay, non-terminating. Okay, listen, write the rational numbers in decimal form. Decimal form, directly you can input it. You can go this directly. 13.25. So 13 by 25. That means 5 square, right? What is not there to make this as a terminating decimal? 2 square is not there, right? You can multiply 2 square. 13 2, 13 4 is double 2652 by 100. 0.5. Same thing. Here 2 power 4, 2 power 4, 5 power 4 is not there. Multiply with 5 power 4. You will get answer here. Same. 2 power 1, 2 is missing in the numerator. 5 square. Yes, 1 2 1 5 is missing, not 2 5. 23 5 times 25 times 115, 115 by 2 power 3, 5 power 3, 2 5 is 10,000. That means 0.115 answer. You can do rest of the questions, right? Easiest questions only. If you observe that examples, you can do that one. And then express the decimal numbers using the form of E by Q. Write the prime factors of Q. What do you observe? Right. It is terminating decimal, right? Terminating decimal, I can write it as 43 123 by 1000 into 1000 by 1000. It can be written as, I can write 2 power 3 into 5 power 3. Right? What do you observe means the terminating decimal, when you convert the terminating decimal into fractional form, rational form, the denominator is in the form of exponential form, which consists of 2 power m or 5 power n or 2 power m 5 power n. Right, it is, look at here, 1 2 0 1 1 12011, 120011, 12000. It is non-terminating, non-recurring, right? Non-terminating, non-recurring. That means it is irrational number. It is rational number only. I will explain the 43.12 recurring. We have 8th class question, right? Okay. We need to convert 43.12 recurring into decimal fractional form, right? I will assume this as x equal to 43.12, 12, and so on. Recurring means repeating, right? Let it be equation 1. How many digits are recurring here? How many digits are recurring here? 2, right? That is why I will multiply equation by 1 by 100 in the left hand side and right hand side. This will become 4312.1212 and so on. I am treating as equation 2, and then next I will subtract equation 1 from 2, right? 100x equal to 43 1 to 4301 to 2 and so on, by x equal minus 43.12 and so on. Anyway, after decimal you will get 1 2 1 2 1 2 only. You will get 0 here, and 12 2 minus 3 we will take bar 12 minus 3 9, right? 12 minus 3 9. You will have 0 here, and again you will take bar 10 minus 4 6 and 42 6 9. 100x minus x 99x. 99x equal to 42 6 9. We will left with x equal to 42 6 9 by 99. This is the fractional form of 43.12 recurring, right? 12 bar. Recurring means bar only, right? And then next I can say one direct step. 43.12 recurring, directly take total number 4312 minus 4312 minus, look at here, 4312 minus how many digits are there before decimal? 2 digits, right? What is that number? 43. Subtract that 43 by how many digits are recurring after decimal? 2, 99, right? You will get answer 4269 by 99, right? This is the answer. That means you can go for you can write fractional form of this number as like this, for 4269 by 99.